Hi everyone, what we're going to do is solve this optimization problem. It's sort of a classic problem here. We're going to find the point on the line y equals 2x plus 3 that is closest to the origin. So let's check it out. First of all, I'm going to sketch the graph of the line, which shouldn't be very difficult. I have y equals 2x plus 3. Let's do a little reminder that this is m equals 2 is the slope. B equals 3 is the intercept, the y-intercept. And let me move this a little bit. So, okay, let's work on the y-intercept first. So for the y-intercept, I'm going up 1, 2, 3. So I get that y-intercept point right there. And then the slope, even though I wrote it as 2, I can think of this as 2 over 1. So I go up 2 over 1. And I get this other point, up 2 over 1, here's a point. You can also think of going down 2, when I say up 2, so that's clear that because it's positive 2 goes up, 1 is to the right by 1. You could also think of this as negative 2 divided by negative 1, so you go down by 2 to the left by 1. Okay, so spend a bit of time on that. Anybody disagree with that? Seems like that's right. So the origin is 0, 0. All right, so here's 0, 0. What we're trying to find is a point. Sort of, I have an idea what that point is just by looking at this graph. Maybe you do too. But we're trying to find the point closest to 0, 0. I think it's maybe over here, right there. Now, what we do is we draw a line segment to the point x, y in the graph, and a line segment between that point in the graph and the origin. And I'm going to label the length of that as d. And we have a formula for d, which is from the distance formula, which is a formula that people memorize. Let me show you well, there's different ways. Okay. D equals the square root of x1 minus x2 squared plus y1 minus y2 squared. That is the usual way that you see the distance formula. I'm going to square both sides. Back to why I do that. But if I square both sides, I don't have a square root anymore. The way I like to show this is d squared equals change in x squared, because that's what x1 minus x2 is, plus change in y squared. See, it's essentially what I'm doing here is between these 2 points, what am I doing? This is the Pythagorean Theorem. That's the distance formula where I have this little triangle here. So it's change in x squared plus change in y squared equals d squared. Okay, that's sort of like overkill doing that little, talking about that too much. But we do need to use the distance formula. So I have x1 minus x2, so that makes x minus 0 squared. I'm trying to find this d, so I take the change in the x's squared plus the change in the y's squared. So d squared equals x squared plus y squared. That is that's our formula. For these constraint problems or these optimization problems, we have a formula, and we're trying to find, in this case, the minimum for d. But we don't have a constraint yet. The constraint is that xy has to lie on the line, which means that y equals 2x plus 3. And we use that to substitute for y. We take 2x plus 3 and put y in there. So d squared equals x squared plus parentheses 2x plus 3 squared. So I take y and I put 2x plus 3 there. Now, why am I using d squared? If I wanted to, I could use d with the square root, but I'm looking ahead and thinking I have to take the derivative of this because I'm going to find critical numbers. It wasn't my idea. It was the author, or anyway, that's what they do in the textbook. I'm going to call this d squared fx because it's a function of x now. So from the very beginning, I wanted to find x and y that make d a minimum. Then I substitute for y, 2x plus 3. I want to find x that's going to make d squared minimum. But anyway, if I find x that makes d squared minimum, that's the same x that makes d minimum. So let's just write this down, and then we'll just go ahead and find the critical numbers. How are we going to find the critical numbers? We have to take the derivative. This is sort of elementary derivatives right here, but and we should be able to do this. If we can't do it, it's an issue, it's a problem. So let's check it out. What's the derivative of x squared? 2x. Now that was okay, but what about this next part where I have 2x plus 3 squared? I have to use the chain rule. What am I going to get there? 2, whatever's inside to the first power, and what's inside is 2x plus 3. Now what for the chain rule?
Then you do 2x plus 3, the derivative of that, so it's just add 2.
Right, so the derivative of 2x plus 3 is 2. So you have to have that. And so this becomes 2x plus, all right, 2 times 2 is 4, 2x plus 3, 2x plus 8x plus 12. I'm using the distributive property. I pretty often make a mistake on that, but that's not good. But 2x plus 8x is 10x plus 12. That's f prime of x. So critical numbers are where the functions, where the derivative of the function is either undefined or equal to 0. So this is defined, this function f prime is defined for all x. So let's set it equals 0 and solve. So 10x equals negative 12. X is negative 12 over 10. And negative 12 and 10 are both even numbers, so I can divide both by 2, and I get 6 over 5. Now, I was looking at this, and I was sort of leading you all into saying that the closest point is negative 1, negative 1. But according to this, if I did it right, it isn't. It's negative 6/5 is the x-coordinate. And we'll find y by using the constraint. So finding y, we go all the way back to y equals 2x plus 3. It's often the case that me and other people make tiny mistakes after doing all this calculus. 3 is the same thing as 15 over 5. You multiply the top and bottom by 5. Numerator, denominator by 5. And so negative 12 plus 5 is 3/5. So we have the point negative 6 over 5, 3 over 5. If you look at the picture, do you think that's true? I mean, it should not be, it should be something close to what the picture looks like. It seems believable. And what was the question? Did they ask for the distance? I think they just asked for the point, right? Find the point. And then never hurts to just look up the answer in the back of the book. All right, so 4.7, number 21 is negative 6/5, 3/5. That's what this point is. It's more down like this. It's over here. Let's change my picture, just make it even better. More like down there. That's xy. Okay, are there any questions about this? Heard a yawn. Okay. Crickets. All right. Thank you. Click like, comment, and subscribe. Thank you so much.